Welcome to the Health Deli, your local stop for a fresh take on community health topics. Come on in, grab a number, and let the guys behind the counter, Mark, Ben, and Mike, tell you about today's specials.
Well, good day. Welcome back to the deli. It's another glorious day in the Health Deli studios here on the campus of Ferris State University in the television and digital media production studios. I'm joined today by MJ and Andrew. How are you guys doing?
Hello.
So good, thank you.
Excellent. So today I'm gonna.
You're joined by two other people too, Mike.
Yeah, wait, what am I, chopped liver?
No, I like liver.
Wow. You've practiced that. You practiced your opening. I was going to give you a compliment, like, wow, you actually practiced the opening. That's nice. And then you just, yeah.
That's true. But
Introduce me to chopped liver.
it's okay. I will introduce you. We are joined by Mark Young.
Thank you. Thank you. And Benjamin Pronafract.
Oh my gosh, thank you. That was
the
lovely.
scholar.
The scholar. And it's a beautiful day out right now. It is the middle of summer.
Yeah,
Finally, it stopped snowing, I think, yesterday. And so we can get ready for summer.
Yes.
Wow. Yeah, I'm just so happy you guys are here. But as long as you're here, you might as well be useful and tell me what you're working on for future episodes.
I got a couple things I've been working on. One is kind of a continuation of our body parts episode, but this one's bodily functions, embarrassing bodily functions.
And again, I am not sitting next to you during that episode.
Oh, yeah, you are.
No.
Right next to
I require a demonstration.
Oh.
I need someone to tell me how they smell, how it feels, just all of those
Gladly.
things.
I'm out.
And then I'm doing one on men's health, kind of working on that too. It's been a while.
Yeah, that should be good. And I am currently working on a follow-up episode at your request, Mike. You're asking about allergy shots. How useful are those for people with seasonal allergies? So I looked into that. And then also another idea that you brought up and then I kind of ran with was essentially prion-related diseases. So things like chronic wasting disease, mad cow disease, those kinds of things. And so that one should be really interesting because we don't really know that much about them. But they are kind of this infectious disease, really weird thing out there. And so looking forward to talking
And
about
even
that.
though they're not common, we've actually had a number of cases in West Michigan over the past couple of years. So it's
There's actually a case series that was done in the hospital that I work at, Corwell, about those cases that you're talking about. So I plan on talking about that a little bit. But
I'm very interested in that.
Yeah.
Okay.
Hot topic.
Well, now I'm done with you guys for the most part.
Thanks.
Andrew, I'm really interested to know how you're doing over there. You know, what's going on in your life?
Well, it's kind of summertime when we're recording this, so I'm here today.
Thank you.
It's great.
Thank you. And MJ?
For me, it's summer class. So we started and
So she's forced to be here.
16 weeks into 16 days. It should be really fun.
Okay.
All right.
Nice.
Well, the reason I brought them into the loop here is because we're going to do the fan favorite part of the show. Probably the only thing they like is let's have Andrew try to pronounce a science word.
I would like MJ to try to pronounce it too. I think it'd be...
but she's going second because she does have a history in healthcare.
Fair.
And so she might have some cheat codes, or something like that.
Some inside knowledge.
All right, Andrew, over to you. Today's word is...
Hematocheza.
that is a epic fail. MJ?
was close.
No.
I mean, it started with an H, so you got the right.
Oh, yeah, hemogeusia.
No.
Whenever we get cheese pizza in the remote video production trailer, I spell it C-H-E-Z, so that's why it said cheese.
That's pretty cool. I like that. That's a cool thing to do.
It's actually pronounced hematochezia. Okay? And this is a sciencey word for the passage of fresh red blood per anus. Okay. And so it's not the coffee ground emesis, so it's not digested blood. So we know if you've got hematochezia, that means you've got bleeding past the stomach.
So would that be indicative of like a fistula?
Maybe.
It could be. There's a lot of different things that could cause
Yeah.
it. But I absolutely loved Andrew's face when you were describing what it was. I wish we could have shown that on air. It was fantastic.
Because in his mind, he was still thinking about cheese pizza. And now we just...
and it sounded more gross.
So we've ruined that for him. So as long as we're ruining things for people, let's talk about influenza.
Ooh, I love influenza.
Well, you might be in the minority.
That's fair.
In particular, I want to talk about a new strain that's out there and been in the headlines recently, and it's referred to as highly pathogenic avian influenza.
Now, avian means birds, right?
Yep.
Well, I am not a bird.
As far as we know.
Why do I care?
Do you want me to give you the bird?
you do on multiple occasions, actually.
So that's a great question. But before I give you the answer, I need to give you some background.
Thanks.
I need to science you up.
He needs it.
I need it.
All right. So influenza is a virus, and it's an RNA virus. And this is important because it only has one strand of genetic material, unlike DNA viruses that have two strands. And the reason that's important is because when these RNA viruses replicate, a lot of them have a tendency to develop errors in their genetic code as they're replicating. That means there's mutations that occur and small changes in how they function and how our body responds to them. And for influenza, we refer to this as genetic drift, or these small changes in the composition of the virus.
Okay, so essentially this is important to us because normally our immune system would see something, and then the next time they see it, we'd fight it off better, right? We call that our adaptive immunity.
Right.
But with influenza, they have these kind of small changes that make it so our body doesn't recognize them anymore.
Or not as effectively or efficiently. And so that's why every year when we have like the new influenza vaccine, part of it's due to our waning immunity over time, but part of it's due to the fact that there's been subtle changes over time in the virus, and we have to keep up with that.
It's kind of like that game that you played in elementary school where they would whisper a secret to one person and they'd whisper it to someone else and they'd whisper it to someone else. And by the end, it was not the same message.
Mark sucks.
I think Mark's really cool.
See, not the same message. I mean,
You're right.
That's what I heard.
Well, that's
All right.
a great example of drift.
Yeah, drifting. Back to the virus, the influenza virus. When we talk about influenza, well, first of all, there's 4 different types of influenza. Influenza A, B, C, and D. And only A and B typically cause infections in humans. Okay. So we're going to, keep that in mind. Now, influenza A and influenza B are quite different from each other in terms of who they can affect and how severe of a disease they cause. Influenza B primarily only affects humans. Influenza A, on the other hand, can infect birds and a whole bunch of different mammal species. So a bunch of different hosts. All right. When we're classifying viruses, influenza B, we typically classify influenza B viruses on something called lineages. And this is, we usually look at where the virus originated or was first isolated. So the current strains that are out there, the lineages are the Yamagata and the Victoria.
So,
lineages.
those are named for geographical places, right?
Right.
Wherever it was. Okay.
Yep. And so that's how we classify influenza B. Influenza A is a little different. But before I jump into that, another characteristic of influenza B is that changes occur in influenza B much more slowly than they occur in influenza A. And as a result, influenza B is usually not that of a concern when we're thinking about a pandemic because we don't get these big changes, in genetic material. And since it only infects humans, there's really not a concern about getting a strain that we haven't seen before, seen in terms of our immunity.
So some of our immunity that we've already had to B may offer some protection for a slightly changed B.
Yeah.
And it doesn't change as quickly, so hopefully that immunity lasts a little longer too. So, makes sense.
And so now in contrast, influenza A, first off, is by far the more commonly encountered of the influenza strains. And this is usually what we see, in the winter months when we're having influenza outbreaks. And influenza A, we characterized by some surface proteins, hemagglutinin and neuraminidase. So hemagglutinin is a receptor. So it's something that's on the cell surface that looks for, something to bind to in the host.
Okay.
And what this hemagglutinin is looking for in host is something called sialic acids.
Okay.
Okay.
And that's just something our cells produce, I'm guessing?
Well, different cells produce these in different parts of bodies and in different hosts.
Okay.
In humans, we typically find these sialic acid receptors in the respiratory tract. And these receptors that we have are relatively unique to humans. Birds, on the other hand, have a different set of sialic acid receptors, and they can be found in their respiratory tract and maybe a few in the GI tract. Okay. And those are relatively specific to birds. And then we got these crazy pigs. The pigs are just kind of like this reassortment vesicle, in that they have sialic acid receptors that kind of cross over from humans and birds and stuff. And we'll talk about the significance of that in a little bit.
Okay. So essentially, in summary, then, the influenza has sialic acid on it.
No.
And it does not. Okay.
The influenza has hemagglutinin on it.
Okay.
And the host has sialic acid, and the hemagglutinin binds to the sialic acid in that specific host. And that's important because specific hemagglutinin types bind to specific sialic acids.
Gotcha.
And there's been 18 different hemagglutinin types that have identified. And they're specific to different sialic acids. And these sialic acids are specific usually to a specific species. Okay. And that's why most of the time we talk about this species barrier in influenza. And we get strains that infect birds typically do not infect humans, and vice versa.
Because it's specific to their receptors.
Right.
Ours are like similar, but not similar enough that they can bind to them.
Correct.
Okay, sure.
Now, the other protein that I mentioned that we use to classify influenza A is neuraminidase. And neuraminidase is an enzyme that helps these newly created viral particles. So when influenza gets into a host, it gets into the cells, hijacks the genetic code making machinery, and creates all these daughter viruses that are inside the cell.
And that's not unique to influenza, right? Pretty much all viruses reproduce that way by hijacking.
A lot of the yes, they will. And so in order to spread the virus, they have to get out of the cell and go and infect another cell. And it's this neuraminidase that helps these daughter cells get out of the cell. And there's 11 different types of neuraminidase. And when we're classifying influenza A, we use a combination. We look at what type of hemagglutinin is being expressed, and we look at the type of neuraminidase that's being expressed by the virus. So we get something like H1N1 or H3N2.
Okay, and H1N1 is something I've heard of before. That was in the news a while back, right? It's a specific kind of influenza.
H1N1, we'll talk about that later, but it even goes back to 1918.
Okay.
And so this specific general strain or parent strain's been out there for a long time. I was probably about 65 at the time, back in 1918. So
I was going to say, you had immunity. You kind of beat me to the joke.
Oh,
there.
yeah. Dude, I'm so up on your jokes. So
Mike brought his A game today.
He really did.
We got to step it up.
Yeah, you're right.
Yeah, you got no chance. Now, the majority of influenza A strains, infect bird species, in the waterfowl. And like I said, that, the sialic acids are relatively specific to those species. So there's a whole lot of influenza strains that are infecting humans, but we usually don't see these infecting birds, but we usually don't see these strains in humans. And, for this reason, the influenza virus, like I mentioned, typically does not cross from the birds to the humans. And we refer to this as the species barrier.
Okay.
And again, this is really important because this is why we don't have just pandemics willy-nilly.
Right. But I'm guessing if you do have crossover, that's where they start having issues.
We'll get into that, yeah.
You're alluding to it.
This seems like a really unfortunate thing that the influenza virus is affecting birds so much, because birds are definitely the most mobile of all animals.
Yep.
So
that's a fair statement.
You know what I mean?
Well, we'll talk about that in a minute, because there is a lot of surveillance that are being done, not only in domestic poultry and birds, but also migrating birds and waterfowl.
Yeah,
so
if it only affected sloths, it would be a different story.
Like you.
I do need to step it up. I got to write some jokes here in just a minute.
So I mentioned pigs, okay?
Right.
And pigs are the exception of this species barrier thing, because pigs can express sialic acid receptors that are found in humans and birds. And this is important because that means pigs can be infected or co-infected with human viruses and bird viruses at the same time.
Interesting.
And when that happens, there's a not so fortunate exchange of genetic material that can occur. So the bird viruses can pick up some of the genetic material from the human viruses, which then maybe makes them more likely to infect humans. And when this happens, we call that genetic reassortment. So we're getting big chunks of genetic material that happens. And as a result, again, these novel strains can then cross the species barrier to infect mammals and humans and so forth. And when we have these big genetic reassortments occurring, we call that a genetic shift. So the drift are the small little changes, and that's why we kind of keep getting influenza vaccines every year.
Right.
And that genetic shift is just like a big jump.
Okay. Interesting. And so, very brief side tangent. That's very similar to what we think happened with COVID-19 back, a couple of years ago, where it was mainly something that was infecting bats, and then now was able to start infecting humans as well. So,
Right.
that's very important for us to talk about because it is relevant to our public health.
Yeah. And so, these genetic shifts, like I mentioned, when that occurs and these new novel viruses can jump the species barrier, that means this new virus has never been seen by that species' immune system.
Mm-hmm.
And so there's a risk that you're going to have spreading of this virus to a whole bunch of folks because nobody has immunity. So we're all naive hosts at that point in time.
You're a naive host.
Hey, we got there.
You
Good one.
finally
Thank
got
you,
one.
thank you. But no, I was going to ask about now when it drifts or when it shifts, like that, would that require a name change? Would that be an H2 or an H3 or not necessarily?
Not necessarily.
Okay.
And that's kind of where we'll talk about this highly pathogenic avian influenza that's out there. They still give it the same base H and N, but there's different little caveats that go behind it. I'm not going to get into all of the
Yeah. So it's still a soft drink, but it might be a Pepsi versus a Coke versus something else.
RC.
RC, I like it.
That's right,
Yeah.
brother.
So you mentioned that this is a problem because it makes it so people who are not immune to it, which is pretty much everybody because no one's seen this, can now get infected. Is there also a change in how our immune system reacts to it? Do we have like more harsh responses, less responses, anything like that?
That maybe.
Okay.
And so immunity and response can be quite different because some of these viruses, and I'll talk a little bit more, cause very severe signs and symptoms and severe disease. But that has nothing to do with your immunity against it.
Okay.
But your immunity helps you clear the virus faster. And so we'll talk a little bit about that. But the thing I want you to wrap your mind around is it's these genetic shifts and this new strain that comes about. These are the ones that have a potential to cause a pandemic because everybody has not been exposed to it. A lot of naive people, and everybody's susceptible, to getting it, and we can't fight it off.
So just like reference. So it sounds like, you have the influenza in the bird. You have the influenza in the human. They cross in the pig, essentially, two different viruses. There's a mutation, okay? And that may or may not happen, right?
Right.
If it does, does that mean then we have a pandemic?
Well, it doesn't mean we will have a pandemic, but it doesn't mean we won't have a pandemic.
Okay.
And
Potential for pandemic exists.
Right. So in order for a strain to cause a pandemic, really 3 criteria need to be fulfilled. First, you must have a strain that produces or elicits little or no immunity in a human population.
So probably a big shift.
Yeah, a relatively big shift, a novel hemagglutinin, let's
Sure.
say, that we haven't seen in humans before. Second, the virus needs to be able to cause a severe infection. I mean, because if it's just a mild infection, whatever.
Right. You're not going to be hospitalized for that. You might just feel kind of sick.
So
then get
a lot
better.
of people might get it, but it doesn't cause a lot of problems.
Right.
Mhm.
Yeah.
And the third thing is these viruses have to be capable of sustained human-to-human transmission. So just having that big genetic change is not enough to cause the pandemic, but we need all these other things to occur as well. And that's really important, especially that sustained human-to-human transmission, because that tends to be kind of one of the limiting things a lot of time is, somebody might pick up a virus from a pig or a bird or a cow, but they're not able to transmit it to other humans.
Okay.
Oh, interesting. I never thought about that.
So you're probably asking yourself, Ben, what's the probability that a novel strain will actually produce a pandemic?
That's great. I think that was similar to what you were asking about, Mark.
Yeah,
how likely is that to actually happen? Yeah, because I'm sure this kind of stuff happens fairly regularly where you have this kind of crossing and mutating. So, yeah.
Well, so let me kind of address this in two parts, okay? So the probability, let's take a disease X. And disease X is a term that's used by scientists and the World Health Organization to refer to an unknown pathogen that could emerge in the future and cause, a serious international epidemic or pandemic.
Okay.
There was research that was published in 2022 that found that the chance of pandemic with having a similar impact that COVID had. So COVID was a pretty significant pandemic.
I would say that.
Wait, what?
So let's
I would
say,
actually agree with that.
what is the chance that happens again? And they predicted that it's about 1 in 50 in any given year.
That's actually higher odds than I was expecting.
Yeah. Well, let me spin it another way because Mark is over there. He's still trying to figure out what this means because he thinks in percentages.
I do.
And so this means that your lifetime probability of anyone having to experience a pandemic similar to COVID is about 38%. So in your lifetime, you would have a 38% chance of experiencing a COVID pandemic-like event.
I think we all have a 100% chance, actually.
Yeah, so I guess that's my question then. So since we've already had one of those, does that mean I now have a 0% chance of having a second one?
Let's talk about that a little bit more. Mm-hmm. So our last several pandemics and close pandemics have been SARS viruses,
right?
The severe acute respiratory syndrome virus,
MERS
and you know what? We had always thought it was only going to be influenza. And so let's look at our past pandemics with influenza. And since 1500, there have been 14-ish influenza pandemics. And since the 1880s, again, I think I was in high school at the time.
Yeah, you probably
we've had
newly married.
Just a few kids. I mean, back then that was acceptable. Well, so that's just what we did because the bears and dinosaurs would eat us.
A lot of epidemics happening,
bears and dinosaurs, both.
Oh dear God. So since 1880, there were well-documented influenza pandemics in 1889, 1918, 1957, 1968, 1977. In 2009. And that's approximately one influenza pandemic every 36 years.
Which it happens to be the kind of age for a generation, right? Every generation.
Yeah.
Kind of interesting.
So of all these pandemics, not all pandemics are created equal. Mm-hmm. All right. And the 1918 pandemic was the worst influenza pandemic on record. And this caused probably, approximately 560 or 550,000 excess deaths in the United States, and killed an estimated 50 million people worldwide. And this are probably a gross underestimation of really the burden because at that time we weren't really tracking everybody down, didn't have good death records and stuff like that. And this pandemic in 1918 was caused by a novel H1N1 virus. And when this pandemic occurred, it was derived by reassorting two pre-existing swine influenza viruses. So again, pigs were thought to be kind of the reassortment vesicle.
What a swine.
Huh.
Are we going to continue?
Yeah, let's go.
Okay, let's continue. Now, that was a bad pandemic. Nobody can argue with that. Since then, we've had a number of mild pandemics and near pandemics, okay? There have been a lot of near pandemics. And what does that mean? So let's say 1976. In 1976, there was a military outbreak of a swine-adapted H1N1 virus.
Okay.
That we had a lot of outbreak in military barracks, but there was limited person-to-person transmission. And it occurred in the military barracks because crammed in together, not a lot of air circulation and so forth. In 2003, there was another near pandemic, and this was with a highly pathogenic avian influenza strain, H7N7. And this virus infected poultry farms in the Netherlands, and it actually spread regionally before it was contained. But about 86 poultry workers and 3 contacts of those workers were infected and developed mild.
That was my question. Was it all, did they think, from avian to human transmission? Must have been some human to human transmission.
Well, they said, right there, probably about 3 contacts. So,
Okay, so
3 confirmed human to human.
Maybe not very transmissible.
Correct.
Human to human. I got you.
And then in 2003, we had another highly pathogenic avian influenza near miss. It was an H5N1 strain. And there were some spillover infections in humans, causing a concern that, if this adapted a little bit more, this could result in a pandemic. Well, that never really happened. So that, again, shows you that even though we have a lot of near misses, the potential for a pandemic, isn't as great as everybody, wants to believe.
So I guess one question I have that, Mike, is how do we know that these near pandemics had happened then? Because it sounds really hard to track that, right? Like there were 60 patients or whatever in the Netherlands. So how are they able to identify that, yep, you have a novel influenza strain. All of these people have it. How that sounds miraculous to me that our surveillance is able to pick up on such a small blip, it seems like.
Yeah. And I want to get into that right after the Healthy Minute.
Let's pause for the Healthy Minute, brought to you by the Winery at Young Farms. Today's Healthy Minute is keep your colon healthy. Colorectal cancer is one of the most common and preventable forms of cancer. Early detection through regular screening can significantly improve treatment options, outcomes, and survival rates. Screening tests can identify precancerous polyps, allowing them to be removed before they develop into cancer. For most adults, it's recommended to begin regular colorectal screening at the age of 45, though those with a family history or other risk factors might need to start even earlier. There are several screening options available, such as a colonoscopy, stool test, and others. Your healthcare provider can help you determine the best method based on your personal health profile. Prioritizing colorectal screening is a proactive step in safeguarding your health. It's a small investment in time that can have a profound impact on your future well-being. If you are over the age of 45 or have a family history of colon cancer, schedule your colorectal screening today. That was the Healthy Minute, brought to you by the Winery at Young Farms in Mecosta, Michigan. Please visit www.thewineryatyoungfarms.com for more information. Now, back to the Health Deli.
Boom, chicka, boom, healthy, 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 healthy. Andrew's dying to talk about colon
realized
screening.
I'm almost to the age for that first screening.
Oh my gosh!
All right,
Mike,
That
how
sounds
many
like an
colonoscopies?
episode. That sounds like an episode.
Let's all raise our hands. Who's had a colonoscopy?
I turned 45 this year. I'm already scheduled.
So
Excellent.
I
Love
want to
hear
throw
it.
this out there. Everybody's like, "Oh my gosh, that sounds horrible. I'm not going to have that done."
Mhm.
But nowadays most offices will put you under. And what I remember is, first of all, having some of the best bowel movements of my life leading up. Thank you, pre-meds.
The bowel
And then
prep.
getting into the room, counting backwards from 199. And then I woke up and I saw my wife and I said, well, when are they going to do it?
Oh,
So it was not painful at all. So please.
well, it's one of those things that is not, it's nobody's favorite thing to do, obviously, but it is so important, especially if you have a family history.
Yep. And I mean,
Exactly.
catching that early can be a world difference in how that
Oh,
disease
yeah.
progresses, right? So,
Yes,
yeah, very important.
I dealt with a lot of patients that scheduled endoscopies and colonoscopies, and their biggest complaint was the prep. And I'm like, don't let the prep set you apart from getting the results of that test. Just go through it. It's miserable. Get it done.
We are definitely going to have to do a colonoscopy episode. Maybe Andrew will get you scheduled, and maybe we can do the Andrew's colonoscopy.
That would
And-
Oh my gosh.
Oh.
We could do the episode live in the room.
I'm looking right. There's an online certificate. I could get the online certificate to perform it.
The School of Digital Media now has a drone. We'll figure it out.
Let's go.
Oh man. Well, let's get back to the topic at hand and get our mind out of our colons for a minute here. So these influenza strains, historically human to human transmission, but you know what? Humans didn't go very far. You can only ride your horse so far, or the boat took weeks. So a lot of these cases were like stuck.
Makes
Now
sense.
with global, climate change and the global international travel, we travel very quickly and can spread viruses all over the place. And so as a result, there's a even greater need for surveillance.
Mm-hmm.
And so that's what we, have been trying to do. And what we've learned in the past is a lot of these novel pandemic strains of influenza first appear in waterfowl and poultry in Southeast Asia. Southeast Asia is a bad place for drug-resistant bacteria and influenza strains and other viruses. Don't know what it is. Might be the climate, might be the diversity in species, might be deforestation and stuff like that. But that seems to be where a lot of stuff happens.
Interesting.
And since this, knowing that we've seen these pandemics in these strains in wild and domestic birds, several agencies worldwide routinely monitor which influenza strains are infecting birds. And in the United States, the Animal and Plant Health Inspection Service, APHIS, of the U.S. Department of Agriculture collects specimens from wild birds, commercial and backyard flocks, wild mammals, and livestock.
Okay, so if I'm understanding this correctly, you definitely need you need to move, right, to spread the virus. If everybody stayed in the same spot, it probably wouldn't be a pandemic, right? So it needs to move around. So like in 1918, that was right at the end of World War I. So people, for maybe the first time in their lives, were moving from country to country, probably contributory to that. And then in this case, we have these birds in Southeast Asia. Now, I don't know enough to say, but I mean, are there any migratory?
Then why are you still talking?
No, I'm asking. So, is there a migratory bird that comes all the way to North America from here? Or how is it getting here?
So, I mean, it's not necessarily that they come from there to here, but they can infect other birds, which have different migratory patterns.
Goes a little ways.
And they tell a friend, and they tell a friend, and so on and so on.
It's like a relay race.
Yeah.
And then that infects a human who gets on a plane and comes to the United States, something like that, I'm guessing.
Or the birds
Planes
come,
are like
or the
big
birds
birds.
True.
Or infect some swine.
come. Oh my gosh.
So it infects Mike.
All right. Let's
got
get on to the topic at hand, this current strain of highly pathogenic avian influenza. I'm going to drop a little history on you. So get ready.
I love history,
I know.
actually. I'm
Come on,
excited.
Mr. Peabody, get into the Wayback Machine.
That was my favorite show.
So back in 2020, it was noted that there was a reassortment between a poultry and domesticated poultry and wild bird virus that led to the emergence of a highly pathogenic avian influenza strain for an H5N1. Okay, and this strain then, over the course of the next several years, had a history of infecting birds and other species. And these wild bird adapted highly pathogenic H5N1 viruses were first identified in Europe in the fall of 2020. And they spread across Europe into Africa, the Middle East, and Asia. In January of 2022, a subset, which they call a clade, of this H5N1. So H5N1 is like the big nomenclature, and then these clades are the subvariants. Okay. And the clade 2.3.4.4b, tuck that one in your hat.
What do each of those numbers mean, Mike?
Well, I could tell you, but you wouldn't understand.
2 means this, 3 means this, 4 means this.
See, that's all I needed.
So, but you need to know that this certain specific subvariant of this H5N1 infected a 80-year-old man who raised ducks in England, okay, in late December 2021. So that was the first known human infection with this highly pathogenic avian influenza strain, but it was a relatively asymptomatic infection, and there were no sustained transmissions or severe illness. So again, in terms of our pandemic potential, no sustained human-to-human transmission, and very mild disease.
Right.
Okay, so people, let's keep an eye on it, but we're not worried. In February, in Peru, they reported the H5N1 virus infected sea lions. And they found this after there was death of hundreds of sea lions that began in January of that year. So this is important because we had a bird virus now that jumped to a new species.
Right, yeah.
So now it was infecting mammals. So again, the potential for that to be able to jump that species barrier was demonstrated. From late 2021 to 2022, the predominant H5 strain that was causing poultry outbreaks worldwide, was identified as this H5N1 virus. So now we had worldwide infections in poultry with this specific strain. So that clade that I had mentioned with this H5N1, because there's a whole bunch of different viruses that typically infect birds, but this one was becoming, somewhat prominent.
Interesting.
In January of 2022, this strain was first isolated in wild birds in the United States. And then in February of 2022, the APHIS confirmed the presence of this highly pathogenic avian influenza strain in a commercial flock in the United States. In November of 2022, I know a lot of dates, just hear me out here. China reported a human case with this H5N1 virus. And this was an individual that was exposed to poultry. This individual developed critical disease and died.
Ooh, that
so
sounds
now,
like a check mark for
so
that
now we're
pandemic.
having, maybe in certain populations we have highly pathogenic in humans.
Or could that have suggested that there was further mutation that now it's causing these very serious
Possibly, because
infections?
remember, we have these like the big shifts,
Right.
Called the shifts, but then we have simultaneously going on some of the
Yeah,
drifting.
those kind of like smaller
And so when you
drifts.
get the shift occurring, now you get something with the potential, and you're waiting for the small changes, the drifts to occur, to have the explosion.
Right. Wow.
And keep going on. During the course of 2022, we found this H5N1 virus in a number of different mammals in the United States and in other countries. So now it wasn't just sea lions and birds, but they were finding it in foxes. They were finding it in mink. They were finding it in a variety of other different mammals. So we had a lot of jumping the species barrier.
Wow. So that seems wild to me. And I don't expect you to know the answer to this, Mike. Is that because one singular virus was able to infect all of these different things, or was it just several different subspecies, subvariants that were able to then go out and infect their individual thing? Because that seems wild to me that the same virus is infecting all of these different mammals.
Yeah, and it could be the same virus. It could be slightly different clades. But again, it's just that small change then makes it able to jump the species barrier.
Right.
And once it jumps to mammals share a lot more of those sialic acid receptors, a lot more in common than we do with the birds. So the fact that we had so many different mammals being infected was really significant.
Right. And that was, I'm sure, a red flag that humans may be on the horizon.
Maybe next.
Yeah.
And so
Wow.
they're the first case, since the first case in 2022 in that asymptomatic duck, raiser in England, there've been at least 13 additional cases of this highly pathogenic avian influenza in humans. 6 have been severe, 2 have been mild, and 5 have been asymptomatic. So that's
Okay.
getting a pretty good percentage of severe, of that. And there's been 2 deaths reported worldwide.
So though that actually is alarming to me, though it's obviously a small number, but that distribution, because if some are asymptomatic, then they're walking around. But if 50% have, at least some pretty significant symptoms. So
Yep.
that makes me
And
nervous.
so, now we got the potential. So we've got a virus that jumped the species barrier, can cause severe disease. The only thing we're missing now is a sustained human-to-human transmission. And that's what we're lacking with this. And now, keep moving forward. By 2024, this strain, this H5N1, was being isolated from numerous species, including cows, goats, chickens, and so forth in the United States. And we've got a map from the USDA that we'll throw up on the website to kind of show where these different species were found and so forth. And then in April of 2024, the first person in the United States tested positive for this highly pathogenic avian influenza strain. And this was the first reported cow to human transmission. So the cow had been, infected, and then, this farmer was infected. So now we've got transmission between mammalian species. Okay.
Wow.
And, so this leads to a thing. So these were in dairy cows. And yes, unpasteurized milk from sick cattle collected at 2 dairy farms, one in Kansas, one in Texas, tested positive for this, and that's where you get all of these, things. Oh my gosh, the virus is in my milk.
But wait a minute, you said unpasteurized.
Unpasteurized, correct. And
Okay.
so, they're looking at different pasteurization techniques to verify that the pasteurization will actually eliminate the virus. And if you ingest the virus, there's probably a relatively low. That's not how influenza gets causing infections in humans,
right? Yeah.
unless you're blowing it out your nose and aspirating.
Well, that happens a lot to people around me when they're drinking milk because I make great jokes.
No, you don't.
and
Happens to
then
me every day.
Shoot milk out their
So
nose.
let
I
me
think
let
about
me
old jokes you've
let
told
me
me,
bring
Mike.
this closer to home for y'all. Okay.
I wish you would.
So on March 29th of 2024, the USDA's National Veterinary Services Laboratories confirmed the highly pathogenic avian influenza strain, this H5N1 strain, in dairy herds in Texas and in Michigan.
Oh, that's where we are.
Yes, it is. So it's close to us. Also, there have been a lot of chickens in Michigan. One of the largest chicken operators in Ionia, Michigan, was noted to have it, and they had to. I love this term. They had to depopulate the flock.
Oh no!
And that's why
I
if
think
you
that's
went
what
in,
chicken farmers do anyway.
and that's if you walk into the store, we were having egg shortages.
Okay.
Oh, these were, I see,
Yeah.
egg-laying chickens. Okay.
So again, to date, this highly pathogenic, we've had only 2 cases reported in the United States, the one in Texas and one in Colorado.
Now, just to be very clear, though, if you bought a chicken that was infected with this and you cooked it, that should be
enough
fine,
to
right.
eliminate the virus because they're not heat tolerant.
Yeah.
Okay.
So don't worry about that at the moment.
But that is frightening. So right now there's only been 2 cases, but you've very clearly outlined that we're heading in a dangerous direction.
Right.
And so who knows what the future will hold.
Let me help you out just a little bit here to ease your mind a little bit. So they've tested these viruses to see if they're susceptible to the drugs that we currently have. And yes, currently the viruses do not demonstrate resistance to our neuraminidase inhibitors or baloxavir.
Okay, so like Tamiflu, also Tamiflu, like the
Right.
normal influenza stuff.
Right.
Okay.
Also, you remember back in the COVID pandemic where this was like, boom, new virus. And we were like, what the bleep is this?
Yep.
And we're like starting from scratch for treatments for vaccines. That's not the case with influenza. We already have treatments and we know that there's no resistance. And we also have candidate vaccines against these viruses that are developed against that specific clade.
Okay.
And so we're there, we're ready to go. It's important to note that the current seasonal vaccine will not provide protection against this novel strain because it has an H1N1 and an H3N2.
Now, when you're saying current seasonal, you're talking 23-24. I don't know when this episode's going to air.
Correct.
The 24-25 May. We don't know.
No, it won't.
It won't.
It
Okay.
won't. They've already set what that's going to be, and it's not going to be in this. Well, they've got this set up for because they still don't know if this is actually going to cause sustained human-to-human transmission.
Gotcha.
So
Okay.
what they've got is they've got the capability to produce this vaccine, but they're just sitting there waiting, ready to go. And then they were like in 2009, they had a pandemic strain of a vaccine that you all went and had to get.
Right. So essentially, they have it ready. If this does become a problem, we can respond to it more quickly than we did with COVID.
Right.
And hopefully, it's much less of an issue.
Right.
Yeah.
And so, again, is this going to be a big deal, this H5N1 strain? Well, maybe. It's been shown to cross the species barrier. It's been shown to cause sustained transmission in some mammalian species, not humans, and it can cause some severe disease. So that's bad. A little change might mean it goes sustained human-to-human transmission. On the positive side, this is influenza. We have tests already developed. We have vaccine candidates, and we have medications that can be effective. And so we don't have to go from scratch. So, is this going to be a big deal? Is this going to be like a 1918 pandemic, or could this cause like a near pandemic or a 2009? Seriously, this is a pandemic? It's too early to tell.
Gotcha. But even in the kind of worst case scenario, we will be better prepared than our most recent pandemic.
We would hope so. But again, we're humans, so we're dumb and we don't learn from our mistakes.
Right. So make sure you keep your window closed, right? Because if you leave your window wide open, influenza.
Oh my gosh. I hate to end on something that bad. But we're far over time, and I don't want to give Mark another opportunity to say something like that bad joke.
I've been working on that all week.
So hurry, run, put up the close sign, lock the door. Let's Lysol everything and stay away from the birds.
Thanks for stopping by the Health Deli to sample some of our wares. We're open 24/7 on Facebook and Twitter at The Health Deli, or visit thehealthdeli.com to send us a question or find any of our locations. Please come again. We will be regularly stocking the shelves with fresh content and new wellness specials. As always, we want to give a special thank you to Andrew Tingley and the crew at Ferris State University's Television and Digital Media Production Program. Until next time, so long from the Health Deli, where the topics are tasty, the takes are fresh, and the discussion is free.
Oh my gosh, that was horrible. An influenza. Oh.
That was a good episode, I thought.
Really stuck the landing.
Yeah, it's all how you go out.